So if we take a look at this one, it's asking for the pH. It gives us concentration because, again, it's big M for concentration, and it has hydrochloric acid there. Do we need an ice chart for this one? No, we don't. Well, how do you know that? Julia? It is a strong acid, good. How else can you kind of trick the problem into telling you that it also is a strong acid if you didn't know?
It's like giving you the equation away.
It is giving you the equation in a way, that's good. It also doesn't give you something that we need if we're going to do an ice chart and solve the whole problem. Does anybody know what that would be? Andrew? The what? Okay, so we can actually figure out the reactants. That's what Julia was just saying. Like, it gave you the equation because we know that HCl is going to break down into H plus and then Cl minus. Oh, I see what you're saying. It's not giving you the concentration of the reactants. Is that what you mean? That's actually what this number is right here. So this is going to be our concentration of the reactants. Julia? It doesn't give us K, exactly. So because it doesn't give us K, how can we do an ice chart and then solve for like X if we don't know K, right? We would have two variables. So all of those kind of things come together to help us realize that, okay, strong acid, we don't need to use an ice chart, which means this number that's given, that's our initial concentration. And if we have 1 times 10 to the negative 6 concentration of HCl, when H and Cl break off from it, we have the same numbers for those as well. So this one would be 1.0 times 10 to the negative 6. Same with this. Okay. Now, how does that help us solve for pH? What do we now know that we can use to figure out pH? All right. We now know H plus is this, right? And you guys know the pH equation. pH equals negative log of H plus. So because we know this number, now we can plug this into our calculator and solve for it. So let me rewrite it. Then we plug this in our calculator. Let's give it a try. It should come up to be 6.00. Okay, so we plugged it in. We got pH equals 6. There's 2 sig figs here. Remember, the whole number with pH doesn't count for sig figs. So we're going to have 0, 0. 6.00 pH. Okay, any questions with that? So now you guys are pretty good with if you have a strong acid, which was either of these problems here, you don't have an ice chart, you use what they gave you as your initial, and then you just kind of split it apart there, and they have the same amounts. Now the only thing that where it can get a little bit more tricky is if there was multiples of one of these things, then over here you'd have multiples of it too. But we'll see an example of that shortly.